Hi everyone, this is Mr. Blitzstein. I hope you're doing well. In case you couldn't tell by the title of the screencast, this screencast will be dealing with the area formulas for rectangle, square, and triangle. You may have already printed out the note-taking guide, and if so, now would be a great time to have it handy and fill in things accordingly. If you did not print one out or didn't want to, please just take whatever notes make sense for you, and of course use them as you need. So let's get right into it. A rectangle, as I imagine you may already know, is a four-sided shape, as known as a quadrilateral, that has four right angles and has two pairs of parallel and congruent sides. So again, in both these diagrams, all the angles are right angles. And as far as congruent, at this point, the markings indicate the top and the bottom are congruent, the right and the left are congruent. Those sides are parallel as well. As far as the area of a rectangle, that is simply calculated as doing length times width. So the one side times the other side will get the area for a rectangle. A square, again, I imagine you know what a square is, but it is officially a regular four-sided shape or a regular quadrilateral. Regular just means that all the sides are congruent and that all the angles are congruent. If you want to use fancy math words, regular means a shape that is both equilateral and equiangular. So again, for squares, all the angles are right angles and all the sides are exactly the same, or they are congruent. For the second one, this is indeed a square. It's on its side and it's been rotated a bit. So you might be thinking about the word rhombus or diamond. Those are close, but a square again has all the sides being congruent and all the angles being 90 degrees. As far as how to find area of a square, it's pretty much just side squared. For what it's worth, it really is the same thing as a rectangle. It is length times width. But for a square, the length and width are the exact same. So which is side times itself, or side squared. And our third and final shape is a triangle. Again, just simply defined as a three-sided shape. Fairly certain you know what a triangle is, but as far as what it could look like, those are three examples. And as far as the formula for the area of a triangle, the formula is 1/2 of the base times the height. Now, please note in all of these, there are right angles being created where the height meets the base, or where the height meets where the base could be. It just depends upon the way you're looking at the triangle and the triangle you've been presented with. So in this first one, the height is clearly inside the triangle. It's making a right angle with this side, which we're calling the base. In this particular one, the height is outside the triangle and it comes down and it makes an angle where the base would have been if it was extended. So in this case, you had to draw the height on the outside and you extend the base. That said, the base itself is just this actual side. It does not include this black dash mark at all. We just need to draw that in there so we could see where the height would have met it and created the right angle. And for this triangle, the height is actually one of the sides, and as is the base. Okay, so we're going to go through 6 practice problems now doing a rectangle, square, and triangle. The first 3 will be relatively straightforward, and the latter 3 will be a little bit more challenging. Either way, I'm going to walk you through all 6 of them. So our first one reads, find the area of a square with a side length of 16 inches. So first thing would be to use the proper formula. So for a square, the formula was area equals side squared. And then we were given the side of 16, so we're going to put that in for our S value. And as far as 16 squared, again, that means 16 times 16, not 16 doubled. Right? So 16 times itself gets you 256. And when it comes to area, the unit is always a square unit. So the side was inches, so the area is going to be inches squared, or square inches. Let's try another. This one is dealing with a rectangle called rectangle QUAD, with Q being 8 units long and UA being 12 units long. So you might be able to do this in your head, but it'll be smart to sketch it as advised just to make sure you're actually labeling it properly. Again, we're going to name it QUAD, and you can draw it pretty much any way you want, as long as Q connects to U connects to A connects to D, and then D connects back to Q. Doesn't matter where you start as far as what point you label with what, as long as Q connects to U to A to D, and D back to Q. So as far as my sketch, here's why I chose to draw it. Again, it's definitely not to scale. That's okay. It's just a sketch for the sake of doing the problem. You don't have to be perfect. And yes, technically with a rectangle, I could throw in little right angle boxes and tick marks, but again, this is a practice problem. We already know it's a rectangle. I don't need to be repetitive and overly do my diagram. That said, as far as how to find area of a rectangle, well, our formula is length times width. In this case, we labeled it properly and we have both the length and the width. They're 8 and 12. So we're going to multiply 8 and 12, or 12 and 8. In doing such, we get 96. And again, we don't know what the unit was, so the dimensions are in terms of units, the area is in terms of square units. And that's problem number 2. Let's try a third one. Okay, this one deals with finding the area of a triangle with a base of 12 centimeters and a height of 9 centimeters. So just as we've done thus far, I'm going to go ahead and make sure I write down the proper formula for a triangle. So that is the area formula for a triangle. Then we were given both the base and height, so I'm going to plug those values in as I see here. Now, as far as calculating, this is 1/2 times 12 times 9, as we're only doing the 1/2 once. The formula says 1/2 times base times height. It is not 1/2 times the base and also 1/2 times height. It's just 1/2 times base times height. So in this case, I'm going to do half of 12 first, and whatever I get, that's going to be multiplied by 9. So half of 12 is 6, and then 6 times 9 would get us our final answer of 54 square centimeters. Feel free to type this all in one step if you'd like, and you do what makes sense for you. This can be typed all at once, and it should get you that same value. All right, that was our first 3. Now our next 3 are still going to be with the same shapes and formulas. It's going to require us thinking a little bit more. And either way, I'm going to walk you through it. Let's try problem number 4. So the diagram below shows the area of 2 side-by-side squares. You're being asked to find x. So it looks like the area of the blue square is 144 square units, and the area of the red square is 100 square units. And as far as these little 1s and 2s, that's just to denote shape 1 or shape 2 or area 1, area 2. They have no mathematical meaning outside of that. X is down here, which seems to me all the way from the edge of this blue square to go all the way to the edge of the red square. Which, if I think about it, seems that it would be maybe this side and this side together should be able to get us that x. So why don't we see if we can play with this blue square first. Well, the area of a square formula is side square, which I have right here, and you were given the area to be 144. Now, some of you may recognize that number or just know in your head, but the idea is anytime you have a square, to undo a square, you'd be taking the square root on both sides. The square root of 144 is indeed 12, because 12 times 12 is 144. So let's try that same logic with our smaller red square. The area formula is the same because it's a square, but in this case, our side square should get us 100. And again, the square root of 100 is 10, right? Because 10 times 10 gets you 100. All right, so we figured out what one of the red square side lengths is, and we figured out one of the blue square side lengths is. Now we got to see if we can actually get x. Excuse me. So I go ahead and I added those in my diagram. Got a size of 12 and a side of 10. So together, that should get your x, which means x has to be 22. 12 plus 10. Let's try a fifth problem. So we have a rectangular yard that's 23 feet by 18 feet, and within the yard is a rectangular flower bed that is 6 feet by 9 feet. The rest of the yard is grass. How many square feet of grass are in the yard? So to me, this implores drawing a diagram so you can actually see what's being described. So let's go ahead and see if we can draw our yard and then put a flower bed inside of it. Again, it does seem like in both cases, those are rectangles. So let's see what we got here. Now, I wouldn't spend forever making your picture. And if you were to draw every single blade of grass, that's just silly. You're going to have some fun with your drawing, knock yourself out, but don't spend too much time drawing it. Either way, I think I did the job as far as I drew the rectangular yard being 23 feet by 18 feet. Again, not to scale, and that's okay. It's just a rough diagram. Then I have my flower bed inside the yard, whether you have it right in the middle, in the corner, off the side, that doesn't really matter as long as it's inside the yard. So I did that, and that was 6 feet by 9 feet, and I in turn labeled that. So we're trying to find the green space, which is not a shape. It's within the rectangular shape, but the green itself is not really a shape we have a name for. So how can we get just that green space? Well, let's think about this idea. If we can get the area of the yard, which is that big rectangle, and take out the flower bed, that small rectangle inside of it, what we should be left with is all this green space, all the grass. And that's what you're being asked to find. Now, both these shapes are rectangles, so we're going to need to find the area formula for rectangles, but then do it for the big one and the small one, and then hopefully subtract. So let's try that. So for the big yard, that's 18 by 23. If we multiply those together, you should get 414. Again, it is square feet, which we'll do at the very end, but that is technically part of the unit or the calculation there. As far as the flower bed, that's smaller. It's 9 by 6, and that area is 54, technically 54 square feet. And as we said, our strategy was to get those two areas and subtract the flower bed, the smaller one, from the larger one, the entire yard. So let's see what happens if we do that. Should get 360 square feet, or feet squared. Okay, let's try one last problem. This problem, you're being told the area of a triangle is 84 square feet. And if the base is 7 feet long, you're being asked to find the height. All right, so let's go ahead and start with the formula that we need for area of a triangle. There's a 1/2 base times height. We were given two values, so I'm going to put them in where they belong. So 84 is the area. It looks like the base is 7, so we'll plug those values in, leaving us having to find h. As we were saying before, it is just 1/2 times this number times this number. So it's not 1/2 times both of them. So we have the 7, might as well take half of it. So half of 7 is 3.5, or 3.5. And our last step is algebraic, so try and get rid of this 3.5. So 3.5 times h, we undo the multiplication by dividing. So dividing both sides by 3.5, and you should get h to be 24, meaning the height of the triangle is 24 feet. Hope that was okay for you. If not, again, feel free to reach out and get whatever support you need. We'd all be happy to help you. Take care.